All right, this is a reteaching lesson from 3rd grade. You can see that the standard here is 3MD8. What students need to be able to do in this lesson is recognize that they have opposite sides of a rectilinear figure are going to be equal. So we're actually going to start with this 3rd grade task. Please watch Lisa's video here. And I think I've talked to most of you about already, like actually cutting out pieces of paper so that students can manipulate this and see that these two green lengths are the same as this one long green length, and these two blue lengths are the same as this one long blue length. So we want to start with that exploration, and then we're going to have students also do it on a grid. So then they can actually count, well, I have 9 here, and that's the same as 4 or 5 plus 4. And then we're going to have them write equations. It would also be helpful if you gave them colored pencils or crayons so that they could color this blue and this blue and this blue and then green, green, and green. So the big idea is that in rectilinear figures, which are figures that are made with combining rectangles, the opposite sides are always equal. So this side and this side are opposite this long one because they're parallel. And so the sum of these two sides is always going to be equal to this side. All right, so after we get that, the next thing that we would want to do is like, let's apply this. So then we're going to do one on our, this would now be like the introduction to new material. For this one, we're just finding the missing side lengths A and B. And this one, A plus 3 is equal to 6. Here, we're missing the longest side, so it would be 4 plus 7 is equal to B. And you can see my equations are over here. Next, we're going to have students actually find the area of these figures. And so we're first going to find what F and G are using our equations, and then finding the area using 2 different cuts. So one way that I can cut this is vertically, and I can label this rectangle 1 and this rectangle 2, and then I'm going to write area of rectangle 1 is length times the width. How long is rectangle 1? Well, it's 7 by 2. And then let's look at rectangle 2. For rectangle 2, my side lengths are 5 by 4. And then have student, like, why isn't it 7? Why is the length for rectangle 2 not 7? Why is it 5? Well, 7 goes all the way from here to here. If I'm just looking from one vertex to the other, it's 5. So 5 times 4 is 20, then we add them together. So again, like, thinking about, like, these are composite. This is a composite figure. Tomorrow we're going to be doing composite volume. Again, the strategy is the same. You multiply and then you add. You multiply to find the area, then you add. You multiply to find the area, then you add. Tomorrow it's like you multiply to find the volume and then you add. The other cut that we can do is this one. So here we would have 7 by 4 for area 1 and then 3 by 2 for area 2. And then this question gets into, like, well, why can't we just multiply all these numbers together, which is like the most common distraction that we're going to see, like the most common misconception that we're going to see. Like, we multiply 7 times 7 and 4 plus 5, and then we add all that together. Well, if I multiply 7 times 7, I actually end up finding the area of a figure that's bigger than the figure that I have, because, like, I found the area of all this space as well, which is not part of my figure. And then when I add it to the area of a rectangle 4 by 5, like, I'm actually finding the area of this space twice. And so, like, we could take a sheet of paper and, like, you could cut it so it looks like this whole figure and say, like, I found the area of this and I add it here. I can't add overlapping areas, and we see that here with these 2 cuts. I don't add overlapping areas, and I also didn't find the area of more than the figure.